This is the screencast for section 3.5, example 1. So now that we know a little bit about logs and exponentials, hopefully a lot about logs and exponentials, we are going to equation solve using a couple of properties. First of all, for any exponential function, f of x equals b to the x, so exponential function, if b to the u equals b to the v, then u equals v. So in other words, if a base to one exponent equals that same base to a different exponent, those exponents have to be equal. Then, therefore, for any logarithmic function, f of x equals log base b of x, if the log base b of u equals the log base b of v, then u equals v. So you don't need to divide by log of both sides. It is just a property that u would equal v. So let's look at example 1. Solve 20 times 1/2 to the x over 3 equals 5. Well, the first thing I want to do is isolate the base with the exponent. So I don't want this 20 times 1/2 to the x over 3 to be there. I want to divide both sides by 20. And that means I will have 1/2 to the x over 3 equals, and then 5 over 20 is 1/4. Well, I've got a property up here that says a base to an exponent equals that same base to the exponent. So on the left I have base 1/2, and I know that 1/4 is 1/2 squared. So now I can write I have the same base on both sides of my equal sign, therefore the exponents are equal. So since x over 3 equals 2, I can say that x equals 6. Which means then that 20 times 1/2 to the 6 over 3 equals 5. And I could check that. 6 over 3 is 2. 1/2 squared is 1/4. 1/4 of 20 is in fact 5. Then now try problem number 1. Find the exact solution algebraically and check it by substituting into the original equation. Okay, so again on the left hand side I have 36 times 1 over 3 to the x over 5. I want to isolate the base and its exponent, so I'm going to divide both sides by 36. So now I have 1/3 to the x over 5 equals, and then 4 over 36 reduces to 1/9. On the left I have a base of 1/3, and on the right I have a base of 1/9, but I know that 1/9 is 1/3 squared. So I'm going to rewrite 1/9 as 1/3 squared. So now that I have the same base on both sides of my equal sign, their exponents are going to be equal. So x over 5 equals 2, multiply both sides by 5, and x equals 10. Now I'm going to check it by substituting it into the original equation. So if I do 36 times 1/3 to the, I think x is 10 over 5 equals, that should equal 4. So 10 over 5 is 2, so 36 times 1/3 squared should equal 4. 1/3 squared is 1/9, and now 36 times 1/9 is 4. So I just followed order of operations, simplified that left hand side, and I do get 4 equals 4, so my x equals 10 does work out.